Hello, and today's purpose of the day is I can write a linear equation in slope-intercept form and graph the equation. Let's take a look at the first example. We'll save the warm-up for class. So graphing and writing an equation in slope-intercept form. So slope-intercept form is, again, y equals mx plus b. Hopefully we recall this information, where m is the slope and b is the y-intercept. Write an equation in slope-intercept form with the slope of 3/4 and y-intercept of -2, and graph. So y equals, my slope is 3/4 minus 2. I'll go to my graph and I'll plot my y-intercept of -2 and go up 3 units over 4. Or I could go down 3 units to the left 4. And those points should all fall in the same line, and it should be a straight line. So again, just really remembering what the form is and where to plug in the slope and y-intercept is the main idea, because hopefully we remember this from, and this is review, but in case not, hopefully it's not too difficult to remember. All right, so write an equation in slope-intercept form with the slope of -3 and y-intercept of 2. Let's fix that. Y equals -3x plus 2. I'll plot my y-intercept up 2 units and go down 3 to the right 1. Or I could go up 3 to the left 1. And again, negative means that my graph should be going in a downward trend from left to right. And again, with these slopes, or with graphing, slopes usually are always left in fraction form. So that's why, up at the number 1, we left 3/4 as 3/4 and didn't change it to 0.75. Now I'm going to add another note or another item to the notes. I'm going to add, if we were told to graph 6x minus 4y equals 16, we would want to first put this equation into slope-intercept form, which perhaps would be then easier to graph. So to do that, I would subtract 6x and get -4y equals -6x plus 16, then isolate y by dividing everything by -4. So I would get y equals -6 over -4 simplifies to 3/2, and 16 divided by -4 is -4. So then I could graph this line, and it would be a bit easier to graph. One other thing that I wanted to talk about as well is, what does this line with a slope of 0 look like? Is that a straight up and down line, or is it a flat line? You got it, it's a flat line. So if we had something like y equals 4, that would be a flat line at y equals 4. Or what if we had a slope with undefined? So if I had an undefined slope, now knowing that a slope of 0 is a flat line, undefined is a straight up and down line, so that would be written in the form of something like x equals 4, where it would be on the x-axis at the value of 4 and be a straight up and down line. So some few things to add to your notes before we move on to the next page. Now we'll look at writing equations in slope-intercept form. So we'll write an equation for a line that passes through a given point and has a slope. So y equals, here what we're going to plug in is the y value. I have to zoom in a little bit more from the ordered pair. And x is the value from the ordered pair, that's the value of x. So into y equals mx plus b, we will find the y-intercept. That's what we'll be missing. So we'll plug the point and slope into slope-intercept form, which is, again, y equals mx plus b. We'll solve for the b, which is the y-intercept, and then we'll write our equation, our final answer, in slope-intercept form. So just recalling the steps that will follow So here, -1, -3, and a slope of 5. So we want to write an equation that passes through that particular point with the slope of 5. So I'll label x, y, and m, and I'm going to plug everything into slope-intercept form. So into y equals mx plus b, and maybe this is starting to come back to you and you're remembering it, but I'll plug in -3 equals 5 times -1 plus b. -3 equals -5 plus b, and again I'm trying to solve for b. So -3 plus 5 is 2. So to write my final answer, y equals, go back to my original slope, 5x plus 2. So that's the equation for the line that passes through the point -1, -3 with a slope of 5. Okay, let's look at the second example. Again, I have x, y, and m, and then I'll plug these into, so it'll say 2 equals 1/2 of 2 plus b. 1/2 of 2 is 1. Subtract 1, so 1 equals b. So my final answer is y equals 1/2 x plus 1. So not too difficult, just have to remember the steps. Now we'll take it a step further and we'll write an equation for a line that passes through 2 points. So very similar, there's just one additional step. The additional step is to find the slope. Use either point, so we can plug either point in. I always like to choose the easier of the two to find the y-intercept. Then we'll plug in the point, similar to the last examples, and the slope into slope-intercept form, solve for b, which is the y-intercept, and we'll write our equation in slope-intercept form for our final answer. So to first find the slope, we will use the formula that we know and remember of y2 minus y1 over x2 minus x1. And so here, if I want to write the equation that passes through these 2 points, to start out, I always like to label what are my points, what are my ordered pairs. x1, y1, x2, y2, and it doesn't matter if I flip-flop those ordered pairs and say, okay, really, 2, -3 is going to be my first set of ordered pairs, and 0, -1 is my second set. It doesn't matter as long as I keep it consistent and know what I called which ordered pair. So I'm just going to write them in order as I see them, and I'm going to first find the slope. So y2 minus y1, chop chop, over x2 minus x1, and I get -2 over 2, which is -1. So my slope is -1. Now I'm going to choose the easier of the 2 points, so I'm going to choose, or the one that looks easiest, but it doesn't matter which point I choose. And I'm going to choose that first point, just because it's got a 0 and a -1, looks a little bit easier to solve than the 2, -3. So into slope-intercept form, I'll plug in y equals m times x plus b, and then -1 equals 0 plus b, because anything times 0 is 0. So b equals -1. So to put it all together, I get y equals -x minus 1, and I don't need to write the -1x. Don't need to write that, it's not needed. So that would be my final answer. Now let's take a look at this last example. So I always like to label x1, y1, x2, y2, and let's find the slope. So -4 minus 7 over 3 minus -6. Chop chop, and that turns to a plus. -4 minus 7 is -11 over 9. So that's my slope. So I get a fraction, that's okay. Now I'm going to pick the easier of the 2 points to perhaps plug in, and I'm going to plug in that second one because that looks a little bit easier. So into y equals mx plus b, I'll say -4 equals m times x plus b. And here I have -11/9 times 3 over 1. I can cancel out a 3 of the 3 and the 9. And -11 times 1 is -11. 3 times 1 is 3. So I get -4 equals -11 thirds plus b. I'll add 11 thirds. We're going to get some fractions. And then I'll say -4 over 1 plus 11 over 3. Have to get a common denominator, so I'll multiply by 3 on the first fraction. So I get negative 12 thirds plus 11 thirds equals negative 1/3. So here I have b equals negative 1/3. So to put my equation all together, y equals, I go back to my slope, which was negative 11/9 x, and then my y-intercept, which was minus 1/3. And that would be my equation for the line that passes through those 2 points. So it's okay to get some fractions. Just got to remember, write out each step if needed, and like I said, it's okay to have fractions in your answer. Thanks for listening. Have a great day. Bye-bye.